All right, welcome back, everyone. We are doing Unit 4, Lesson 4. This is transformations of trig functions. So this is like grade 11, essentially. Many of the same concepts. Your a value is your amplitude. Your period is equal to 2 pi over k. So in grade 11, you probably learned there was 360 over k. But remember, we're not using degrees anymore. So it's 2 pi over k. D value is phase shift right or left, and vertical shift is your C value. So yeah, exact same thing, same general formula. The only difference is now we're using radians as opposed to degrees. Here, let's do example 1 now. So example 1, let's state the amplitude. If you remember, the amplitude is just your a value, the absolute value of your a value. So if your a value is negative, you just don't really worry about the negative value. Your amplitude is just the magnitude, which is just the absolute value. So in this case, a value is 3, and my amplitude is 3. Yeah, just leave that as like that. Period, remember, is equal to 2 pi over k. Remember, absolute value of k, so you don't really care if k is negative or not. And that is equal to 2 pi. In this case, our k value is... Oh, actually, I forgot to mention, it's pretty straightforward. A, k, your d value, and then your c value, obviously. And just remember, your d value is always the opposite sign there, so it's actually negative pi over 3 as opposed to positive pi over 3. All right, so k value is 1 over 2, so 2 pi divided by 1 over 2, and if you do that correctly, you will get 4 pi. That means the period is 4 pi. For this example, phase shift, that's your d value. D value is negative pi over 3. So that's the phase shift left by pi over 3. Vertical shift C value is negative 1, so phase shift down 1. Your maximum value, if you remember correctly from last year, your maximum value is equal to C plus your amplitude, or absolute value of A, same thing, which in this case, C value is negative 1. Your A value, or absolute value of A, is 3, so you add them together and you get 2. That is the maximum value. And your minimum is similar in that it is C minus your amplitude. Remember, your amplitude is the same thing as absolute value of A, which is C, which is negative 1, minus 3, which is negative 4. So the minimum value is negative 4. It's pretty straightforward stuff. Let's graph. Let's get to it. Let's do a nice little exercise here. Okay, here we got our transformed function, which is y equals 2 sine brackets 2 brackets x minus pi over 3 close bracket plus 1. So a value, k value, d value is, remember, positive pi over 3, so it's the opposite, and your c value. We are going to use the same techniques that we've learned in our previous years, which is, mapping notation. So first we have our parent function, and we're just gonna write our key points for our parent function. So if you remember, the key points are 0, 90 degrees, 180, 270, 360. But since this is grade 12, we're not using degrees anymore. We are using radians. So 90 is actually pi over 2, 180 is pi, 270 is 3 pi over 2, and 360 is 2 pi. Y values don't really change. Sine of 0 is 0, 1, 0, negative 1, and 0. Yeah, I got that right. And now our mapping notation, if you remember correctly, it is x over k plus d and ay plus c. That's my mapping notation. In this case, my k value is 2, so it's going to be x over 2. X over 2 plus my d value, which in this case is pi over 3, so plus pi over 3. My a value is 2, so 2y plus 1. So let's do this. Plug in 0 into x, that's just pi over 3. Right? Now, plug in pi over 2. So I'm going to do a few of these in detail so you can see this. So pi over 2 divided by 2, right? And remember, when you're multiplying or dividing fractions, what do? Well, when you're dividing fractions, you take the reciprocal of that second fraction and change the symbol into times. And just so you're clear, whenever you're dividing, it's the same thing as multiplying by 1 over that value. So if I'm dividing by 2, it's the same thing as multiplying by 1 over 2. And if you take a look at division always as a multiplication, it'll save you a lot of headache in the future. So this is just pi over 4. So pi over 2 divided by 2 is pi over 4, because remember, you're just multiplying by 1 over 2. And that's the first part. Now we're going to add pi over 3. And what is pi over 3 plus pi over 4? Plus 3 pi plus 4 pi. I'm just going to do crisscross applesauce, like 3 cross multiply 3 pi, 4 pi, and 4 times 3 is 12. So common denominator, that's 7 pi over 12. And that is that right? Should be right. 7 pi over 12. Okay. Plug in pi. Pi over 2 plus pi over 3. So pi over 2 plus pi over 3 is what? Remember, same thing, crisscross applesauce. So 3 pi plus 2 pi over 6. Some quick math. That's 5 pi over 6. 5 pi over 6. 5 pi over 6. What else do we have here? 3 pi over 2. So 3 pi over 2 divided by 2. Remember, when you're dividing by 2, just think of it as multiplication of 1 over 2. So 3 pi over 2 times a half, it's 3 pi over 4. So 3 pi over 4 plus pi over 3. 3 pi over 4 plus pi over 3. Remember, just crisscross again. So that's going to be 9 pi plus 4 pi all over 12. That looks like 13 pi over 12, right? 13 pi over 12. And our 2 pi, which is 360. So 2 pi over 2, that's just, the 2's cancel, it's just pi plus pi over 3. That's obviously 4 pi over 3. Okay, these are x values. What about my y values? Y value sub into 0, so that's just 1. That's going to be 2, 3. That's going to be 1. Negative 2, so that's negative 1. And then 0 again is going to be 1. So 1, negative 1, 1, 3, 1. Perfect. Okay, so we have our values. Now, something that I will mention is... see how they're all different fractions here? That's kind of difficult to work with. Like 1's over 3, 1's over 12, 1's over 6, 1's over 12, 1's over 3. What I would do is I would convert them all to a similar denominator. So you can choose if you want to put them all over 3, all over 12, all over 6. Doesn't really matter that much, I guess. It depends on the scale that you're graphing, though, because when you're choosing your x-axis and how much to go up by, that's where it's gonna matter. So yeah, just choose an appropriate scale, or convert them all to degrees if that's something that's better for you, and convert them back to radians, I guess, if you want to do the extra step. But yeah, okay, let's graph this. But I am going to, let me see, pi over 6, 2 pi over 6. Yeah, so it really depends on your scale. What I'm going to do is I'm going to make them all over 6. Why 6? I don't know. Pi over 6 is usually a pretty standard scale progression. You could do pi over 12 as well, but then it would be a little bit expanded, your graph. So I'm going to do pi over 6. So how does that work? Well, pi over 3, if I want to convert that to pi over 6, you just times both the top and bottom by 2. So that's going to be 2 pi over 6. This is over 12, so we actually have to divide both the top and bottom by 2. So that's going to be 3.5 over 6. This is already over 6, so we don't have to do anything. 13 divided by 2 is 6.5 pi over 6. And this we multiply, so 8 pi over 6. Remember, I just chose 6. You can choose 12. It might be easier for you to choose 12. The reason why I chose 12 is for the next slide here. When we graph this, I guess I should have used 12, honestly. It doesn't really matter since I'm making the graph myself. Okay. Since they're all over 6, I'm going to have my scale go up by pi over 6. So I'm going to have 0 here. And I'm going to pi over 6. You have 2 pi over 6. You have 3 pi over 6. And 4 pi and so on. So I'm not going to write every individual number since you know what the pattern is. I'm going to kind of skip one and do 1, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Remember, 6 pi over 6 is the same thing as pi. Then I have, 6 pi, so 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and then 12 pi over 6, same thing as 2 pi. Okay, so let's graph this. We have 2 pi over 6, which is 1. Oh yeah, sorry, I forgot to graph my y-axis, so this is obviously going up by 1. So 1, 2, 3, 4, -2, and -4. So let's see, we have 1, so 2 pi over 6 and 1. 2 pi over 6 and 1, that's here. 3 pi over 6, 3.5 pi, sorry, so 3.5 pi. So 3 pi over 6 is here, 4 pi over 6, 3.5 is in the middle here, and that is going to be a value of 3, so that's here. Then we have 5 pi over 6, which is here, and that's going to be a value of 1. Then we have 6.5, so 6.5, what was that? 1, 2, 3, 4, 5, 6, 7, so right here in the middle, and that's -1. And then we have 8 pi over 6, which is 1. And this is how it graphs. If you want to extend this graph, kind of, do this. Your C value, you kind of draw your center of axis. That's where your nodes are. The values that are on the center line. And we can kind of maybe follow a pattern. If you can see the pattern, the X values are kind of going up by 1.5 each time, right? So 1 block and a half a block. Then you have a 1.5 block, 1 block and a half, 1 block and a half. So that means 1 block and a half is going to be here. And the next value, repeating value, is going to be a maximum. So you only have 3 options: a maximum, minimum, or a node. Node being a point on the center axis. If this is the maximum, the next one has to be on a node. And remember, the X value is going up by a block and a half. So half a block and then 1. And we know it has to be a node. And the next one has to be 1, and then half a block, and it has to be a minimum. So it's going to go like that. Like that. And then going backwards, block and a half. And since this is a node, it's going to go on down to a minimum. Sorry, the minimum is -1. I apologize. I made a mistake there. Yeah. All right, so minimum is -1. And now for a minimum, it's got to go back up to a node. So a half and a 1 block. So here. Then 1 block and a half. So a maximum, which is here. And kind of follow the pattern like that. All right, that's how you can extend a graph once you have your 5 points.